How long does it take for you to drive to work in the morning? Does it take the exact same time to drive home in the afternoon? Typically not. There are different traffic patterns in each direction. You may have different one-way roads or even left turns versus right turns that affects your commute time. When you book a flight, you don't only see the time for the round trip, you actually see the time to travel in each direction. When you plan a route to drive using Google Maps or some other mapping tool, the tool doesn't just provide the round trip time from your home and back, it actually provides one-way time. But in the networking world, traditionally, travel time has been only measured via round trip times, even though in one direction or the other, the actual time it may take to transmit the traffic may be radically different. Why don't we do with data networks what we naturally do when we travel? Frankly, it's just a matter of time. In the world we live in, we all have a relatively synchronized clock that we work off of, and we take for granted that everybody's in sync with it. Time is critical, which is why we have atomic clocks to keep us synchronized. But for incredibly high-speed data networks that span the globe, it is not trivial to have a common clock synchronization of high enough resolution so as to allow you to accurately determine one-way times. We at Talari invented and patented a key method for doing highly accurate time synchronization across vast global networks. This allows Talari to measure every packet as it transits the network for both its application one-way time and its network one-way time. Each and every packet is a learning packet for us. No need to probe, only occasionally, when you can measure the real user traffic as it travels each way across the network. The benefit of this is the ability to use your network to its full capacity in each direction. For a time-sensitive voice over IP call, it may be best to use a broadband link in one direction and the MPLS link in the other. This, for example, is very common in long-haul international voice calls. In addition, by using disparate one-way measured paths in each direction, the network applications that require optimal transaction times, like HTTP and HTTPS and VDI, are able to achieve responsiveness superior to any one particular network's ability to provide that. The turns take less time.